Hey, what's up, guys? All right. Let me just check that the audio and everything. All right. Test 1 2 3. Test 1 2 3. All right. Test 1 2 3. Test 1 2 3. Okay. All right. Test 1 2 3.
Perfect.
Test 1 2 3. Alrighty. One second, guys. I'm just sending my friends the links. Worse. I guess let me post it on X. Well. Okie dokie. All right. So, where were we? Let's see. Okay. So, we were solving this problem called Beside the Point from Jane Street Puzzles. So, just a quick recap, you have 2 points that are randomly selected. And then one's blue, one's red. You pick the side that's closest to the blue point, you make it blue, and then you have to check if there's a point on the side that's equidistant to the 2 points. And if there is, that means there is a solution. And then in some cases, like here, there isn't, and that means there isn't a solution. And the goal is to find the probability that there exists such a point if your 2 points are picked randomly. And you need to get this accurate to 10 decimal place. So let's see. So I was doing this basically computationally to try and solve this. So first I made like a little visual thing like this. You can just hit enter and it does like a new run. And so the way you can tell is basically you can draw a line between them, draw a line perpendicular that goes through the point that's in the middle between the two, that line lands on your blue line, that means you have a solution. So like here, lands here, so there's a solution. This point is equidistant between the blue and the red. And then if this line doesn't land on the blue side within the square, then that means there's no solution. So that's the basics of it. After that, we started computing this. So I started out just with this very simple for loop. Of course, it was too slow for our needs. So I think, yeah, I don't even remember what exact performance we got, but it was pretty slow. And then after that, we had a couple multi-thread attempts, and then also a NumPy attempt. So the NumPy one was running pretty quickly. It was doing about 33 million trials in 1 second, and it was eating up all of my CPU. And in terms of the actual value that we were getting, we're at here. So it's about we're getting this, and it was 1, 2, 3, 4. I think we were getting 1, 2, 3, 4, 5. The first 5 decimal places weren't changing anymore as we were running, so they were basically staying the same. Whereas these other ones, they kept changing. So that kind of tells us that the precision is about 5 decimal places, which just isn't enough, really. So, just to show you, I'll make a copy of this. Okay, and I'm gonna delete this just so I can show you how this works. So this is the compute NumPy script. So you basically tell it how many trials you want. So this is 15 billion. And then once every 10 seconds, it will output what the current statistics are, what the probability is looking like. I think, yeah, for some reason, I guess yeah, because this was getting buggy near the end, so I think there is some bug here. There definitely is. Because everything is just zeros for some reason. So it's just not updating properly. So, I mean, let's look through this. Okay, first we have our vectorized trial. What are we doing here? Blue, we're picking an y. Okay, that's the dimension of our array. So, okay, and then same for red. And then this is, we're doing like a little distance bottom calculation here. Subtract the distances, find the closest side, find the midpoint, slope, and negative reciprocal. I guess this is so in case we have like a maybe if this is very close to 0, want that. We want it to be more than at a very small over here. All right, and then we go through. Not even 100% sure how this all works. But somewhere we messed up some. They're not like getting output. We were just getting like. We were just getting all zeros. Oh my goodness. Okay, and then we save progress. So this. Well, cursor. So we let me just add. Wait, how do you ask? So I'm basically worried that like this int is doing something but I want to ask it about. I don't want it to change it. Store them as strings. Seems a little shady. Well, I'm gonna reject that. I feel like this is lying to me. I want to ask Grok. Seems a little fake. Um, JavaScript safe into. This is thousand, millions, billions. Okay, so I don't have to worry about that. So this is fine. Yeah, by the way, this so a bunch of this code here is copy pasted. So it's definitely definitely something I want to refactor a little bit because I kind of want to publish this on GitHub and just have like the different performance options available. Because now I'm actually curious, like I want to get to 10 decimal places of precision. Because I don't think it should be that hard. I think it's a very doable task. I thought there was a I like specifically ask about loops 4 times inside of the units. Variable ID X represents no, 0, 1, 2. So this, I don't think IDX actually matters. It's just treating this as the body. This line creates a Boolean mask. It identifies which earlier in the vectorized. Current IDX side. Sorry, I got distracted. I keep getting messages. Anyways, so we're trying to understand this code here because Grok Grok vibe coded this for us. So I mean I did like the equations. Like I figured out the equations. It just figured out how to vectorize them basically to run a bunch of trials at once, which made everything super fast. Mask equal Okay, so where do we set the IDX? Uh-huh. So 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 okay, we generated a bunch of random points, and the dimensions of the array are the amount of trials, and then I guess it's usually RC. So this is rows. So you have a bunch of rows. You have a bunch of rows. This here is num trials, and then each one has like a coordinate, and this is an x and this is y. Okay, and then d bottom is blue. This is just getting all the distances to the bottom, and it's setting this as the appropriate blue value, and then this is always hard coded to 1. Is that right? Is that right? Because shouldn't it be the other way around? And then distance to the top is 1 minus. Did I get flipped? It flipped the x and y, right? Or I mean, maybe I don't understand this. Set to concise. I always have it set to concise. Because Grok is way too verbose. If you don't tell him to shut up. Okay. Sam's above a separate set of points. D bottom extracts the y coordinates. Blue selects the second column of all blue points representing distance. Y equals 0. Ah, I see. So this gets the y coordinate because that's the position it gets. Oh, okay. Yeah, I see. It gets all the rows and it gets the first. So it selects all of these, but it gets the column that's indexed 1, which is y. And then top, it just subtracts it. Because if we're like at 0.3, we're here, then this is 0.3, then top is 1 minus 0. And then same thing for right and left. And then it stacks these. I guess it combines them somehow into like 1. And then it gets the closest side as an array, which is always whichever argument is smallest. And if it's 0, it's D bottom. If it's 1, it's D top. If it's 2, it's D right. If it's 4, it's D left. Okay. Calculates the midpoint between all of them. And then calculates the slope, which it just uses point slope form, right? This is the y1 minus y2 over x1 minus x2 adds a little thing so that this is never 0 because we'd have to divide by 0. Very smart. And then negative reciprocal slope, which is the slope of the perpendicular bisector. So it's the slope of this line here. Okay. Okay, initializes solutions by setting all to 0. And then it goes and processes each side. So whether it be bottom, top, right, or left. Mask is if this equals idx. If not, if none of them, then we just skip. This shouldn't ever happen, I don't think. But then if it's 0, so the bottom, then we know that y equals 0, and then we need to calculate the x coordinate, which we do by just plugging it into the formula. And then same thing for 1, right or left. And then we return, and we set this to Boolean, and then we return the count of Booleans and the count run. Oh, very smart. Very smart. Very I really like this function. This is very neat. Okay, save progress. We just dumped this into JSON. Nothing serious here. Load progress. So this tries to load the progress. Okay, let's ask. Okay, so we're fine. So these two, maybe we can add a comment. So if we ever go over this, then we'll need to like change this code. That won't work anymore. Okay, and then there's our logger thread. So this takes solutions, trials run, total trials, log interval, save interval, and the file name. And then it says start time while trials run dot value. So I think this dot value is because we need it's like a variable shared between threads. So you can't just normally access. You have to use this dot value. So we sleep. And then current solutions, we get current trials. We log current trials, current solutions, current trials, and the probability. 7 decimal place. And then if it's been enough time for the save interval, then we save progress as well. Then we reset the start. Okay, I mean, doesn't seem like there's anything criminal here. And then finally we have our so the batch size we're running 1 million. So each like numpy one is doing a million. And then we specify these. So first we load progress, trials remaining. Add this. Actually, it could let's do this in like so we always log this. We weren't and actually 7F. All right. And solutions is a value. What? We're just not from multiprocess. Logger equals threading.thread, logger thread. Seems right. Logger.start. And then executor while trials remaining is greater than 0. Current batch. Futures.append. Vectorize trial. I wanna creates a process selection of workers, execute tasks. The with statement is properly managed. Used to store future. Okay. Argument path. Files remaining. Okay. Future in futures. Seem right. Thing about this is a little sus. Something about this is a little bit sus. Okay. So comment indicates start of space where the main place for the submit. Others there. Code now iterates through the Okay, so I mean I don't see any errors here. Um. So I mean, we I don't understand. So, is it because of why are we doing dot value? That seems really weird. Well, I also I mean, yeah, I want to see how the logger takes these and then it uses dot value. So something, I think this here. So
Гуляш готов, ну как бы я попробовала кусок.
they're in the compute initialize. Is vectorized trial messed up? Oh, that's a lot though. So much. That's then oh, he was not a valid. returns a C-type object allocated. Type code or type turns a type of object. Or just pass. This doc is so like not good. So int unsigned. No, this says Q is legit. Maybe this is. I bet this might be amazing to. That's the issue. I don't know. I don't even remember when this broke. Sure. But load progress mess. Means printing, right? And it's then here for some reason. Why is this not? Right? Um, this looks correct. Solutions, the value. Well, let me just or even No, I don't know what's going on. Yeah, I'm not sure. Rights are possible. Never hitting that code is my guess. Probably. That has to be what's going on, because we're not. So why are we never getting that code? Logger thread's working. There is messed up. But if actually Oh, 1 second, I'll be back. All right. I think we need to change the approach here because I think this code is doing something weird. Like like I don't know what this iteration does. Like does that mean it waits for everybody to finish? If I do this. I don't know. I don't remember changing it, so I don't understand why it broke. Oh, did this? Oh, I mean this already. Hope it doesn't make a lot of changes. Kind of scary. Yeah, I wonder how on earth you could unit test this. Doesn't at all. That could be hard. Very hard to. But I mean, definitely possible with the imported. Okay, so cumulative number of trial workers are submit. So set on like not going over the trials. We don't. It's not that important. Process futures as they complete greater future. Seems reasonable. Do this. I want to commit. Nice. Okay, great job, Curse. Very good. Then we get rid of this. Make this. Dude, I feel like this is faster. Because how many is this? This about 400, a little under 400 million. So it's like a tiny. This kind of mess. Being able to. Alright, well, I think what we had. We might want to insert it there. Alright, I mean, we run this. Then we might want to let's see, let's I don't think it should hit any limits now. Checked all the limits. We might be getting to like 6 decimal places. I'm seeing like this 4. Just as I said that. No, we're at 5 decimal. So, yeah, I mean, we could also like write some code that will like tell us what accuracy level we're at, like with a rough estimate. There's some refactoring and cleanup we can do. I also wonder if we could run this on a GPU. I mean, surely if there's a way to run this on the GPU, then it can be much faster. I also wanna gonna make my computer. This made my computer very glitchy. I mean, let's look. Yeah, 100%. No limits. It's flowing through. We can't even. WMI provider host interest. Quite a bit. And it's taking up 2 gigs of memory. Almost 3 gigabytes. Almost as much memory as Chrome. I wonder. Wait for it to save. And I just want to. Okay, nice. So we're still at 5. But this is growing pretty rapidly. You know what? We already got like 4 more billion. Okay, so let's if I run this with like 12 workers, I want mouse is we're still at 100%. I don't understand how that I think we're going a little slower. Like it looks like we're going 200 million in 10 seconds. Where we were at like 400, almost 400. I don't know why it's like regardless. I'm gonna probability. I So basically I'm asking how can I estimate the number of trials that would be needed to get to 10 decimal places of precision. I'm going to explain. Again. It's still running. Make them think. Right, without them. Very slow responses. Virgin's behavior. Process the standard error of the estimated approximately to achieve decimal places. This is the to the 20th. Need we need 10 magnitudes higher. Please, what is it won't even see little. We're like thousand off. And let's so we can also divide that because we know we need to divide that by we're getting like 33. 60. Oh my god. 60. we would need 96,000 years. Because this is how many seconds we would need. This is how many minutes. This is how many hours. This is how many days. And this is how many years. We need 96,000 years at our current rate. Oh my goodness. So it'd be very hard to get there. Very, very hard. This won't work. Can't do it with the simple NumPy approach. Possible. Simply impossible. This is so this is where we're at. We're at 10 to the 10.45 trials. And we need 10 to the 20th. So that is 10 to the 10 as much as currently we have. Oh boy, oh boy. Oh boy, oh boy. That's really fun, guys. I can't explain how much fun. Let's see if we can do this math. 96,000. Wait a second. That's exactly what I got. Dude, this thing is actually not that. I mean, it's like doing math correctly. Grok is smart. I want to try this. I'm gonna try this with ChatGPT. I feel like I've tried similar stuff with ChatGPT before, and I feel like it hasn't gotten it. See what it says. Oh, dude, I hate this. I hate giving feedback because I never know like which one's better. Like you have to like compare and nitpick, and I'm like, I'm just picking a random one. Like, are you really getting useful data out of this? Okay, so it got it right. I mean, it said 10 to the 20th. Okay. And then let's see if it can get Incalculate. Yep. Whoa. Dude, so it goes, it takes a long, like, look. 6 digits, trials needed, 8 hours, 7 digits, 35 days, 8 digits, 9.6 years, 10 digit, 96,000 years. We don't have that much time. Hmm. Running. Running. Tum tum. Okay, well now I'm gonna go and start asking about. Hmm. What involves random number they're highly parallel. Per second. We're at 33 million. So this isn't even gonna help us. Spanish pretty similar. It'll take 10,000 years. RTX. This is ridiculous. Oh. One second, guys. Man, shame. You just can't do. Yeah. Oh, who knew? Who knew we would have such a problem that it would take us 1,000 years, even on an RTX. On CPU, it's not 96,000 years. Dude, that is I mean, I guess that makes sense. That's why they said 10 decimal places. Because I think they didn't want people. So they said 10 decimal places. Can't brute force it. Wonder, I'm just gonna ask, like, I had a bunch of. I'll ask it to. I mean, we achieved the 10x, like, just the GPU versus CPU, according to Grok, would be a 10x, right, from almost 100,000 years. Billion trials a second on 100 A1. A single A100 would need over 1,000 years. 100 A100 would need 16 to 32 years. Isn't that insane? Like, how does that even happen? Seems like a very generic problem. So for 6 digits, 7 digits, we need 35 days. We could get it to 6 digits. What are we at right now? 4910505050404. We're at 1, 2, 3, 4. We're at 5 decimal places of precision. So I guess the only way to solve this then is with actual mathematics. Can't brute force this. Impossible. Sure. gasket. Try this. billion. So if Elon Musk paid us $1 for each truck. Oh, I remember playing around with CUDA a couple years back and get it to run without error consistently. I know what it was. So hopefully they have had uh, GPU with CUDA support. Check if open command. Oh, we don't have it. Right. Well, wonder if it's gonna crash my. We'll be right back. All right. Installation. To Express. It's like a 50% chance this doesn't. It either works or it doesn't. Instead of NumPy, it's using. It looks like it has. $15. We're at 53 billion. 100. Yeah, 15 trillion. So like in 46 decimal. If we run it for 15 hours on our GPU. Just might want to wait for our. This is Alright guys, well, I'm probably gonna call it a day there. And then we'll try this out with the GPU. To try out with GPU factor and code tracking. And then sure. So still have a couple to-dos we can do. So we'll try this out with the GPU. And then clean this all up, add some performance tracking and report. Finish it and then call it done. You guys can run it. Yeah. So thanks for tuning in. Good one.